Hello, everyone, and welcome to IIoT World Energy Day 2026. Thank you all for joining us today. We're excited to have such a great global audience of leaders and practitioners across utilities, oil and gas, and power systems. Before we begin, just a few quick housekeeping notes. Please take a moment to explore the platform and drop a message in the chat if you want to let us know where you're joining from. If you have questions during the session, please submit them using the Q&A tool only, not the chat, okay? So we can track and address them efficiently. We'll be taking audience questions towards the end of the session. And this session is 59 minutes, and I'll make sure to keep things focused, and we will have you out of here on time. Also, we'll be running two short polls, one after question 1 and another after question 5. We'd really appreciate your participation. It helps us better understand where you are in your virtual power plant journey and brings more value to our discussions. And finally, would it be possible to run this virtual conference without our sponsors? Thank you to our sponsors. Thank you to the sponsor of this session, Influx Data. Let's move into today's topic, scaling virtual power plants, data challenges at 1,000 plus distributed asset. You know that virtual power plants may fundamentally reshape grid operations. Instead of relying on centralized generation, we may now be orchestrating tens or even hundreds of thousands of distribution assets, like batteries, EVs, smart devices, as a single coordinated resources, right? So, but behind this transformation, there is a significant challenge, which is data at scale. Now we are dealing with unreliable and heterogeneous edge connectivity, high volume, out of order data streams, the shift from device level visibility to fleet level intelligence, and of course, a strict compliance with grid operator requirements. And today's discussions aims to unpack how organizations are addressing these challenges and what it truly takes to scale VPPs successfully. I'm very grateful that I'm joined by an outstanding panel of experts who have been directly shaping the evolution of industrial data and IoT systems. We have Dean Sheehan, Field CTO, Influx Data, based in Cambridge, UK. Dean brings expertise in cloud computing, enterprise software, and business strategy. He previously had roles at Apkera, Axon, iWave Software, and Enigmatic. His background spans SaaS, enterprise architectures, and cloud technologies. He earned an MBA from the University of Cambridge. Sam Elsner, Vice President, Product Experience, Litmus. Sam specializes in bridging customers, markets, and technology by connecting business requirements with product direction. He serves as both product and development evangelist, translating sophisticated technical capabilities into understandable value for internal teams and external audiences. Alden Nipper, co-inventor of MQTT, CTO and president, Cirrus Link Solutions. Over 45 years of SCADA industry experience, he was instrumental in designing pervasive computing and IoT architecture, co-creating MQTT, now the dominant messaging standard in IoT. Previously served as a president and CDO at Arcom Control Systems and Eurotech Inc. His background spans embedded systems design and SCADA infrastructure, and he holds a BSSE from Oklahoma State University. And I'm Moin Mambachi. I'm a project leader, faculty, and instructor at the British Columbia Institute of Technology, which is a post-secondary student in Vancouver, Canada. And I'm a co-founder of Electro Mentors. My background is electrical power. I hold a PhD in power systems, and in the last 10 years, actually worked in research and development across several impactful nationwide initiatives, like the first campus microgrids in Canada, one of the first substation automation labs based on ICC 150, and currently I'm collaborating with our industry partners on projects relevant to digital twins, smart grids, and VPP technology. So with that, let's move into what I think will be a very insightful discussion, and start unpacking what it really takes to scale virtual power plant from concept to reality. Dean, let me start with you, if you don't mind. What's the biggest obstacle energy companies face when building data infrastructure to coordinate tens of thousands of distributed energy resources as a unified grid assets in VPPs?
Yeah, thank you. First of all, for the opportunity to speak here. So yes, it's first of all, I'm an IT guy. My background is in databases and computational infrastructure. So there is a bias natural in the way I might answer these questions. At Influx Data, we have a lot of energy use cases, classic kind of energy production power plants, virtual power plants, BESS systems and things like that. So I do have a lot of familiarity with this domain, but I'm fundamentally an IT guy. But I think that leads us into what I see as the biggest challenge, and that is mindset. Looking at this strategically, as there's a big change here. So whilst there is a lot of classic kind of infrastructure involved in virtual power plants, a lot of technology involved, there's a lot of technologies new coming in as well. And this, I think this fundamentally changes the problem from shifts the balance from one of OT first, operational technology first, to one of information technology first. That actually the fuel for classic power plants was, carbon and what have you, kind of classic fuel. The fuel for virtual power plants, I think, is more data. And so data plays a much more prominent role in virtual power plants. And so you can't take the technologies that you might have relied upon for the past 50 years and just say, look, we need to push them a bit harder. If we push them a bit harder, we can build a virtual power plant out of a few tens of these things. That's not the case. So, for example, if we take historians as an example, there are others. If we take historians, we can't just push them a bit harder. We need to think about this problem as a data first problem, and kind of be prepared to think a little bit differently. So that's the kind of the fundamental shift I see for me, the biggest challenge. This real-time telemetry that you require now, you can't operate a virtual power plant with data gaps. Having insight across the fleet is what's required to make fast decisions that allow you to sweat those assets to optimize that virtual grid. And so you need that real-time telemetry. You need to make sure that real-time telemetry is available across your fleet, not just out at the site, because you can't optimize at the site. You need to optimize at the fleet level. So you need a combination of all that data being able to come to the fleet level for fleet level decision making by humans, and increasingly by technologies, machines. I nearly said that horrible word these days, agents, but let's just say by machines as well as people. But you also need site level autonomy. That those networks that connect those things together aren't always reliable. They're getting better, but you do need, you can't just lead with a solution that says, well, we'll just get all the data to the center for decision making there, because there is a chance that connectivity might disappear, and you might need to think at the edge in cases of, let's call them maybe a more emergency situations. So you need a combination of kind of site autonomy, fleet-wide view. You also need to kind of normalize all that data from across all those, distributed and divergent. As these technologies are evolving quickly, the equipment you have in sites across your fleet, the different sites will be different as these technologies are evolving. So you need to be able to normalize that data, and so that you can make decisions on a normalized kind of data set. So that's where I'd start this from, is that this is very much about a mind shift. I don't want to say it's IT first, but I'd say it's shifting a little bit more to be IT being more prominent, data being the fuel for virtual power plants. I would say allowing that level of optimization.
That's great, Dan. I really like the way that you described it, mind shifting. Arlen, Sam, do you have any inputs, anything to add?
Well, it is definitely going to be data first. I think we'll get to that. We're going to cover that here shortly in a lot of the other questions. But yeah, I mean, it's definitely going to be a shift in all of the different protocols and the standards that we're looking at here.
I'd say a shift in the behaviors of the messaging systems too. And I know, Arlen, we've been working on edge reporting for a long time.
Yeah.
And oil and gas midstream is a fantastic analogy to some of the virtual power plant pressures that we're facing here. So yeah, like you said, I think we have a good deal of content to cover around that.
Yep.
I'm looking forward to it.
Beautiful, perfect. And that brings us to our second question about VPP. But before that, let's quickly launch our first poll that will give us a kind of a sense of where everyone is in their VPP journey. So I'm seeing some answers coming. Beautiful. So, not currently pursuing VPP strategies. We have some still planning, evaluating VPP approaches. Beautiful. Scaling to thousands of coordinate devices. Running pilots with hundreds of distributed assets, 10%. So that's a good stat here, that it seems that more than 50% are not currently pursuing VPP strategies, but it looks like that things are moving, right? Scaling thousands of coordinated devices is 17% and 13% on the planning phase. Perfect. Thanks everyone for participating. Arlen, VPPs, you know that they're generating significant industry buzz these days. In your opinion, what's the most overrated aspects of VPP technology that distracts from the foundational data challenges that ultimately determine operational success?
Well, I think it's going to be the fact that we're talking about, I mean, I did a little bit of research here in the definition of VPPs. We're going to take thermostats and batteries and air conditioners and, EV chargers, and we're going to combine that all into this fantastic virtual power plant. And I think we all realize that the challenges there are, as we sit today, probably only 2% of those devices are compatible with some sort of a data structure. And if we go back to conventional SCADA, well, we're not going to do it that way. We can't poll. And I looked at a lot of the categories of equipment out there, and they said, oh, well, we have APIs, we have REST APIs. Well, that's not going to work, because everything is going to have to be event driven, and we're going to have to get that data. To Dean's point, that data is going to have to land somewhere. Now, I would say the equivalent of that is starting to emerge is that manufacturers all have this concept of a unified namespace. And in a unified namespace, you can start publishing information so that at least it lands somewhere where now we can start managing it. We can do those high granularity decisions. But until we get to that, it's still going to be a dog's mix of edge compute, conversion, all of these to try to get this into a true, consumer from the ground up type of a VPP. And I think that, it's the overrated aspect of, yes, we have home automation, we have smart thermostats, we have all of this Internet of Things technology, but trying to wrangle that into something that's going to scale is going to be the challenge. And I think it's really overrated. If you read the buzz line of VPP, you would think, oh, we're just going to go out, we're going to hook up all these devices, everything's going to work great. But that's not going to be the reality.
Absolutely. Dean, Sam, do you want to add something?
Yeah, I think it's spot on, Arlen, and I love how your comments didn't have to include AI at all for overhyped, right? There are bigger skeletons than just that.
Yeah, absolutely. And I would pick up very much on that kind of normalization. And you mentioned unified name scheme there, Arlen, and I agree. Whether or not you buy into UNS, it doesn't matter as a concept. The idea that the only way you can make wide scope decisions across a fleet is if you've got a degree of normalization, and normalization without loss as well. It can't just be take the subset of features that are, or metrics that are consistent across all these things. You can't lose the original data, but you also need it in a normalized view as well. So that in some regards even doubles the data, a normalized view of the data and its raw data. So,
and Sam, the reason I didn't mention AI is that until we get that corrected, AI it's not even in the equation.
Yeah, AI operating on bad data. What more of a nightmare could we have?
Yeah, we see it all the time. I mean, just go out and look at the internet at the results of what AI and bad data gets you, right? So, yeah, appreciate that.
Perfect. Awesome. Sam, another question that might be very important is that traditional power plants have those kind of predictable connectivity and centralized monitoring. But when it comes to VPPs, they may rely on heterogeneous and often unreliable or sometimes not secure networks like home Wi-Fi, cellular network, and consumer devices that can disappear at any time, right? Any moment. So how does this shift in communication reliability and topology influence the design of data architecture?
Yeah, it's a really good question. I was glad to. I felt lucky to be the one to answer this one. Arlen, I'm thinking back to the decades of oil and gas and midstream, especially. There's so many overlaps, but so this is where I'm pulling a lot of my expertise from. In my opinion, there's differences in responsibilities for ensuring the connectivity stays up when you have just an enormous heterogeneous network of things to talk to. In oil and gas and midstream, we have really astute telemetry collection systems. And, there are pains and suffering that we go through to manage them. But the world is run on these polling engines for a couple of decades, 30, 40 years at least. So we do want to try to get away from them and have more event-driven communications. But sometimes you just have to deal with what you get for APIs or data interfaces and Band-Aid the rest of it. So these polling engines, when we need to use them, they're the body of knowledge and domain expertise that has gone into them is pretty significant. And so they're big, somewhat, essentially monolithic systems that are really heavily configured at a central location. And then they have access to all of the external entities. And it's really, really, really good at connection retries and data integrity checks. And the drivers that are in those polling engines, the communication utilities, become really smart, and they can anticipate noise and remove extra bytes and swap payloads around just to make sure you can kind of rehydrate the message to the extent it's safe to do so. But as we've, been working on, at least since I've been around, so it's getting on now 16, 17 years of doing this, just connectivity and industrial automation spaces. Edge event-driven data reporting, MQTT and Sparkplug are incredible technologies. And so when and where we can, we certainly want those utilities, whether they're small home automation gear or connected cars, we want them to report themselves. But the problem becomes, you need to do more than just understand what's happening. You actually have to understand what's happening at different time frames and in different reactive situations. So you can't just have a stream of unsolicited, standard, constructed, can't change messages coming back from this network of entities that creates a VPP. You need to be able to proactively interact with them too. Sometimes request an update to their running state, sometimes to actually change something and affect an operational difference, right? So, to me, the VPPs, we're going to run into things like balancing peak demand and reporting things correctly in real time. And then we're going to see multiple distribution mechanisms. Some of them are going to be edge reporting where we can. Some of them are going to be the old request response because we have to. And then inside of that behavior set, we're still going to need to do spot check, spot analysis, and command and control. So the topologies are not necessarily going to be as inefficient across the board, but they're certainly going to be very mixed. Whether it's resilient networking technologies like MPLS or mesh routing standards on top of this, but even just the protocol level behaviors themselves. We need to receive stuff, we need to ask for stuff, and we need to control stuff.
Beautiful. So basically, we're moving from that unidirectional kind of communication to bidirectional, and also somehow moving from centralized to some decentralized distributed command and control architecture.
While maintaining all of the behaviors needed, right? Distributing the responsibilities of data reporting differently for efficiencies, but not losing any functionality. That's the goal.
Yeah. So Dean, Arlen, anything to add here?
Not particularly. Covered it well, Sam.
Good. That was good. Arlen, one other question. What is one capability or requirement that VPP operators consistently underestimate until they try to scale from hundreds to thousands of assets? What's your input on this?
Well, so like you said, I've been doing this for 48 years now. And I can remember when a large SCADA system was 10,000 tags. And then, a large system was 100,000 tags. And now we have customers that are in the energy. We have one customer that's basically taking solar, wind, and battery installations and trying to pull all that into, let's call it a quasi VPP. And they went from 100,000 to 1 million. They're now probably at 14 million tags. And when you start looking at that scale, all of a sudden, all of these problems that the three of us have been talking about, just all of a sudden explode. They mushroom within that infrastructure. So again, going back to the elephant in the room on this notion of VPP is that I talked to some of our customers that are doing it, and I've got, IEEE standards, SPAN standards, all of these standards that are out there. And, we can't even agree on how Modbus works, and it's been around for 50 years. So how do we, the elephant in the room right now, as far as underestimating this, is how do we get to the point where we start having a VPP UNS, if you will, a unified namespace that you can publish this data into? Because honestly, other than technologies like MQTT, again, I've got a hammer and everything's a nail. How do you put that type of infrastructure together? And so I think we have to start having that conversation, or we will be knitting together. We'll have protocol converters, we'll have edge of network converters, we'll have protocol going to edge of network. And it's never going to be that, I want to bring up my infrastructure, go subscribe to some information, and I want to be able to learn everything I need to know in a few seconds. And that's really what we're talking about here.
Absolutely. Thanks for that, Arlen. Dean, Sam, anything to add here?
Yeah, I just wanted to say that Arlen, you articulated the problem so well. I think that this is where we need to get to. This is what digital transformation end state is, a ubiquitous ability to peer into the running systems of the organization, whether it's physical systems, industrial settings, manufacturing, or business systems, right? To get there, there's a lot of technology and there's a lot of know-how and there's a lot of domain expertise. But it's hard because there are multiple domains to consider, and you have to get people who traditionally haven't needed to collaborate or agree on one way of doing things to sit down at a table and get them to agree, or else you end up with,
Right.
connectopus proto systems, multi-protocol, aggregation tools, and And it's not a bad world. Hey, I've found my place in it. It's wonderful. I love this heterogeneity, but it is one of the things. If you dial back to Amazon style digital transformation principles in the early 2000s when they were scaling, where a lot of the Amazon Web Services tech came from. It was a lot of internal agreements. It's a lot of it was a cultural shift for them as much as it was tech built. So those are the hardest pieces and the slowest to change.
Yeah, I think it's that disparity, divergence is I think as Arla mentioned, there are a lot of standards out there that are relevant to VPP. But that's the problem. There are a lot of standards, and I don't want to suggest, what we need is another committee to create an umbrella standard. That never works. Standards on their own never work, let alone a standard over a standard. So it's about having technologies that are flexible and understand that actually, even if you've got one standard, the standard today will not be the same standard tomorrow. So standards change. So you've got so many kind of dimensions of divergence. And I think it's about choosing technologies or understanding that you need to embrace that. If you think you can sit down and get agreement, that's probably that's a recipe for failure. Expect that you're not going to agree and adopt technologies that are that you can change the mapping on the fly, go back and revisit the mapping without losing the history. So I think that's that diversity, that divergence and lack of standardization or multi-standardization is probably the biggest source of failure.
Dean, it really makes sense that you'd have folks like Arlen who are promoting Sparkplug and MQTT and really shared tools. But when it comes to inside of an organization, we need to be able to understand and appreciate those shared tools. But we're probably going to end up with more than one of those shared tools, at least right now. So it's important to have the internal processes down, and because even though there are standards, like you said, there are a lot of them, and there are fit for purpose standards that it might just come down to a device vendor that's your favorite device vendor and they don't support your favorite protocol. So you just have to deal with what they've given you, right? Anyway.
Thanks, Sam. Thanks, Dean. Let's go to our next question. Question for you, Dean. Early VPP deployments often emphasize site-level monitoring of individual assets like batteries or EV chargers. What fundamentally changes when transitioning to fleet-level intelligence, and why do many data architectures fail at this stage?
Yeah, I mean, we've already mentioned the network, and so we won't revisit that. But clearly, that connectivity has to exist in some regard. But maybe leaving that aside for a moment, not to revisit it right now. Just thinking about just the data volume. Is 10, 100, 1,000 times more, and you can't throw one solution to that problem is go, we'll just sample the data a little bit. We'll reduce the volume of data coming at us by sampling every 100th value at the edge, and therefore back at the fleet level, we're still dealing with the original volume that we could handle, with our technologies could handle. It's like, well, you can't do that now, because you've got, not only are you aggregating at a fleet level all these different sites, there is an increasing level of instrumentation, increasing level of resolution. Not just historically these types of technologies were once every 15 minutes, then it goes to once every 5 minutes, then it's once a second. Now we're into 10 hertz, 100 hertz to 200 hertz. So you've got changes going on in the sites, increasing the data volume, and then you've got all those sites coming to the fleet to make with the same level of, you need the same level of fidelity. You can't miss bits and pieces, because that's when you'll start to miss the alerts. You won't be able to make decisions based on the most up-to-date information. So that it's the aggregation of that data is a massive problem. And I think if we go back a little bit to the network, if there is disruption, then it's like when it reconnects, what happens? Okay, so now there's a backlog of data sitting in the site. Do we just fill in the gaps? Where do we prioritize that refill of data, given that the networks might already be approaching saturation? The worst thing you want to do when a network comes back is dump a load of data at it quickly. The chances are it's still kind of recovering. So, prioritizing the data that's coming from the sites when there is network reconnectivity, so that you can prioritize what are probably more real-time decision making and then backfill data. That's important. And I think, obviously when sites have been offline, even if it's temporarily at these kind of rates of data at hundreds of hertz, if they just glitch for a little while, the data is then coming in, and it's not necessarily out of order with respect to the site, but it is out of order. It's out of significant kind of temporal sequence with respect to all the other sites. And how do your central systems reorder that data, put it into whatever it's doing in terms of indexing and storage, so that they can actually, they're not, so they can cope with that data kind of coming out of order. So these are all important things. So I think the big transition is, the many orders of magnitude of increasing data volume that's approaching kind of the fleet level insights, and also, like I say, the massive increase in resolution of data that's available and also required to operate these kind of things safely, but also in a way that's kind of really maximizing the opportunity of these assets to kind of yield revenue.
Thanks, Dean. Yeah, to save some time, let's just pause here for our second quick poll. And this one actually focuses on your biggest challenges in building VPP data infrastructure. You can check all of that apply. So I see some results coming, and it's a very interesting result here. Just waiting for others to answer. Perfect. So I see that 6 answers go to H, providing ROI for VPP infrastructure investment. And beautiful. 26% is providing ROI for VPP infrastructure investment. We have 19% handling unreliable connectivity across distributed assets, 14% on meeting grid operator telemetry and compliance requirements, and also skill gaps, finding talent who understand both grid operations and distributed systems. And of course, we have some answers for managing out of order and late arriving data at scale, as well as achieving fleet level intelligence from device level data and data storage cost for long-term retention requirements. And of course, bridging consumer IoT devices with utility with great reliability needs. Fantastic. Thanks everyone for answering this question. Sam, let's move forward with another question on metrics. Grid operators require aggregate capacity and response performance metrics for VPPs, right? But operators still rely on device level data for diagnostics and optimization. So how do leading operators balance these kind of competing requirements without duplicating infrastructure?
Yeah, it's a great question. So it's the case that uniquely utilities and energy automation settings, scenarios in which automation controllers, devices, logic controllers are used in utilities and energy monitoring and production, they have a rich assortment of interface standards. Like Dean was saying, there's lots of standards. And these standards are really, really well, very, very complete, very functional. So these are like a distributed network protocol version 3, DNP3, IEC 61850, IEC 6870. Those specific standards make programming and accessing complicated data sets truly easier than they ever have been before. they're not necessarily new standards, but they have not been widely adopted, maybe in the last 10 to 15 years by commercial vendors and other types of large end users. These are standards that had typically been deployed almost exclusively by the energy management operations software systems, like the network operations control centers, the NOCs and the others. But a lot of other they've become much more widely supported by open source systems and commercial vendors. So Kepware and Autosol and Litmus and Matricon and others saw a good opportunity to start supporting these interfaces. So we have these rich standards used with intelligent electronic devices, IEDs, which are the electrical systems, utility systems, sort of RTUs. Anyway, the IEDs are fancy devices with a lot of really nice interfaces. So we can do different things at the edge with those that help us create a solution for the question, which is really how do we do two jobs at once without duplicating the infrastructure and the effort? So given the IEDs in these settings have sophisticated interfaces, the data sets themselves are accessed. Oftentimes there may be normalized and processed at the edge, even buffered at the edge. So those standards even help us with data reporting and data quality issues. The standards support unsolicited message streams back, just categorical, give me everything type of data streaming, and control standards, control protocols, or spot checks for data. So you can do a lot of behavior sets, whether it's slow historical analysis from a data stream from one IED to spot checking the state of relays at the IED while getting data streams back. So given the advancements we've seen in network interfaces and devices for these particular settings, it is actually quite easy to take advantage of those interface protocols and the well-designed software on the other side of it and the devices themselves to serve those two stakeholders, the operational stakeholders and the larger aggregate capacity stakeholders. So what happens after we get the data, whether it's normalized or not, right? Partly how we make use of this to serve these different stakeholders, we'll get the information back and we'll begin to create a unification. And maybe it goes into a single repository, like a single namespace with a shared type system. But regardless, the data sets come back, they're processed, and they're put into different data products. So sometimes the data products, the information structures, and the interfaces that they're served over are only supported by maybe the aggregate capacity and response team software system. So we create a data product and we hand it over a language just to them in the way that they understand it. Other times at the same exact moment, and these are all be, parallelized stream processing workloads, we'll create a data product and we'll hand it over to the operator. Or maybe the operator has a local access panel on site, and we're able to deliver that data product, maybe even back to the site and present it, or the site's IED is sufficient to tie into some general purpose HMI solution like, an ignition dashboard, or something from TatSoft, or just like an easy composable HMI window at the edge to make use of that operational data. But between the sophisticated interface standards that we're able to use against these devices, and then the well-established practice of enriching data through extract, transform, load, and creating data products and finding different interfaces which to expose those data products, the duplication of infrastructure and the duplication of effort is days gone by, thankfully.
Beautiful. Thanks, Sam. I appreciate that. And I think that brings us to data accuracy in terms of decision making, which is going to be our next question. Dean, you know that VPPs monetize flexibility through frequency regulations, demand response, capacity markets, right? So how does your data infrastructure support accurate bidding and dispatch decisions? And what are the risks when your data misrepresents available capacity, in your opinion?
Yeah, I mean, we've spoken a lot about what the data infrastructure needs to do. It needs to be able to handle that, that connectivity, that large volume of data, on reconnectivity, the reordering of data to make sure that, now the feed is back, you've got the data appearing in the right order that you can kind of, start forming decisions based on the up-to-date information, ignoring the gaps that might still be being backfilled. So I think we've spoken about that quite a bit. But I think, if we look at what are the implications in the absence of that, where are you? And I think, a worst situation, and we're dealing with a lot of safety critical systems here, so there's lots of levels of protection, but it is possible to operate these things in a way that's dangerous. So if you are operating with data that's out of order, out of date, seemingly out of date, you can be making decisions that could essentially, risk those significantly capital expensive kind of assets, putting people's lives at risk. I don't want to suggest that would happen, but at least, if there weren't the safety critical kind of, controls on the devices that you hope are there, we know are there, then it's certainly possible at the fleet level to, in the absence of real-time information, to be making decisions that could cause significant kind of problems, fires, God knows what have you. But coming back to, not the kind of safety critical things, but more about the revenue side of things, these VPPs they're arbitrating. They are based on information, and also quite short windows of time as to when to make, not only when to make the decision, but when that decision and that opportunity for making money is available. It might be a few minutes, few hours. You miss that, that's it. Your revenue opportunity is gone, and maybe not only just your revenue opportunity to maximize them, but to set yourself up for the next cycle of, typically going through daily cycles. So if you make a bad decision today, then actually you might be putting yourself in a situation where you can't capitalize tomorrow because you didn't discharge when you could have, and now you can't actually recharge at a lower cost point to service the network, the VPP kind of the following day. So I think it's all about, VPPs are there to sweat assets. They're arbitrating all the supply and demand and the capacity they have within them to smooth that out. And if you can't do that because you don't have information, up-to-date information to make those decisions, then your opportunity for maximizing revenue is evaporating. And so I think, like I say, stepping away from the safety critical things that you could do wrong and badly in the absence of data, and thinking more about, it's coming back to less safety critical. It's more about that inability to maximize on the potential to make money, and deliver kind of good service from the VPP because you don't have all the information you need.
Perfect. Sam, Arlen, anything to add here? Quick.
Nope.
Perfect. Maybe our next question for Arlen. What were the critical infrastructure? What were the critical inflection point where VPP operators had to fundamentally re-architect their data infrastructure? And what would you do differently from day one, knowing what you know now?
Well, I'll go back to that example of our current customer with 14 million going to 100 million tags. We've got the ability within our infrastructure, within our system, to create user data types, UDTs. And those, basically contextualize all of this protocol data that Sam was talking about. So the problem with protocols, even, again, legacy protocols don't contextualize our data. They give us register information, and then we give it engineering high, engineering low. We give it, what machine was it connected to, all of the contextual data that you need if you're going to get this massive amount of data in. And remember, we're not, with VPPs, we're talking about emerging equipment as well as conventional equipment that's already in the field. So now we're across a much wider our landscape, if you will, of interoperability that we've got to worry about. So starting with, again, building that UNS from day one, whatever that UNS starts looking like. Again, Sam mentioned it, there is a spec out there called Sparkplug, and Sparkplug lets us contextualize our data. It lets us publish a model of a IED. And now we can, instantiate that model. It's got contextualized information. We know where it came from. We've got our timestamps. Dean, we've got the ability to backfill historical data, but not create a data storm. So all of those things we've thought about over the last 45 years that we've all been doing SCADA. So I think if we take lessons learned from our last 45 years, what works good and what doesn't work worth a crap, and then can bring that forward and think about that as you're architecting your next very large infrastructure system.
Thanks, Arlen. Sam, Dean, anything to add here?
Yeah, I'd say that's one of the hardest parts is the contextualization piece. And one of the most exciting things about the VPP piece is that we may be able to take advantage of some standards like the DMP3 IEC standards that help normalize that work, or help distribute the responsibility of that work a little closer to the device programming side.
Thanks, Sam. And I think my next question is also somehow about maintaining compliance. Sam, you know that ISOs and grid operators have strict requirements for telemetry accuracy and auditability, but let's say you're coordinating thousands of unreliable consumer devices. So how do you maintain compliance when a percentage of your fleet inevitably goes dark?
I think you build in the expectation of tolerance for that type of thing, right? Whether it's algorithms that might compute and fuzz based on the last state if the certain points in the graph are not there anymore. Maybe you're able to interpolate so that you don't make that bad a determination without that data there. And then it's about how can you reestablish connectivity and get that data back flowing just automatically and as soon as possible, which goes back to the earlier part of the discussion about, do we have self-reporting edge devices? Do we have a central polling engine that does client-server communications and reaches out and tries to reestablish connectivity? Do we have redundant network paths to the equipment? There are so many layers of discussions and decisions that have to happen before something like that overall expectation and assumptions are ready to be levied. That I don't want to say it's figured out in the sausage making process, but to some degree it is.
Thanks, Sam. Arlen, Dean, anything to add?
No, I think to your point, Sam, just like these devices over my shoulder here, those devices are publishing their information. We're not polling them. We're not having to get a register and then say, oh, well, that's actually a 0 to 1024 is actually 0 to 100 PSI. We can't afford to do that in this sort of a architecture. We've got to have, edge of network devices that can start telling us what they know. And we got to forget this mentality of, I don't know anything, therefore I must poll.
To the extent that the time and devices and systems and people allow it, there just should be a category of base information that's always published. Well, I think we can all agree on that. And then, we end up figuring out how to reestablish network paths. Sometimes it looks like client server options against that interface set are the right way to go. Against that single protocol pipe, have a query option to reestablish, or just initiate something from the receiving end to reform the TCP connection, for example. But again, all of those things are they don't have to be done at the polling engine central point. You can do that through all kinds of different network layers and interface standards. So the more Arlen's point, the more we keep that in mind as we start approaching these designs and integration systems, the easier time we'll have making those data products and getting them to the people who need to make decisions with their business.
Thanks, Sam. Thank Arlen. Let me open this last question up to all of you, maybe 1 minute each. Looking 3 to 5 years ahead, as VPPs potentially scale from thousands to, let's say, millions of assets, what data infrastructure capabilities will distinguish leading operators from those that struggle to keep up and scale? Maybe we can start with Dean.
Yeah, I think Arlen's mentioned it a number of times, UNS, and I think standardization, normalization is really, really important. But I think also along with that, being flexible, appreciating that things will change over time, and not trying to get caught up in a taxonomy hell and trying to categorize everything. You won't get out the starting gate. So I think you have to take on change will inevitably happen, and look to choose technologies that can help you adapt to that change and normalize it and renormalize it as things change. So I think certainly that's a really important starting point for me. Yeah.
Sam?
Yeah, I'll pick up on that change. It's just like any, the adage is strength is not in standing firm. Strength is in bending, right? So, to me, the work is the most ferocious at the very beginning, so that you can build a structure and system that allows you to bend and deal with variances later on. Because your point's well taken. If you sit down and try to agree on what a data product should look like, or what a use case model should look like, or what the taxonomy should look like, or even the ontology of a single well site. It's really hard. But if you can agree on just the tools on how to deal with the differences instead, that's a recipe, in my experience, for success. And a better way to ice break the conversation too.
That's right.
Thanks, Sam. Arlen?
Well, the ones that are the leading with millions of devices going forward, the ones that we'll see that are being successful are the ones that take the approach that I was talking about, that Dean was saying, is that they've created a UNS that's flexible enough, that's resilient enough, and has got the performance required to basically do a successful VPP. And I think, again, we have customers that are doing that today. They're being very successful at it, but it does take a lot of organization to do that. So those will be the ones that are successful going forward.
Thanks, Arlen. I appreciate that. Thanks to all of our panelists. Let's just now turn to the audience. I think we've received some great questions, and thanks, Sam, for answering those questions. But maybe I can read those questions again and see if Dean and Arlen has any other comments, and you, Sam, as well. But before that, if you have any questions, please just put it in the Q&A chat box. Not the chat box, but the Q&A box, I mean. One question was, how much of room does UNS have in power and utilities digital transformation landscape, given the availability of global IEC standards for data communications? Arlen, do you have anything to add here?
Well, we just did a Prove It, or Sam and I did a Prove It conference here in Dallas a couple of weeks ago, and I think the thing is that, people get frustrated because they go, oh, I went out and there's really no definition of a UNS. And the definition of the UNS is a hierarchy of information that works for your company. And so, yes, you should be able to map any data that you want to go into that.
Perfect. And the other question from Thomas was, how does the UNS and normalization discussion relate to the standards like 61850 or I3X in the context of VPP? Dean, Sam, do you have any talk on this?
Well, I think Sam was going to talk more on the 61850, but looking at what SESME's doing with the I3X, that's really just a model in that you can go out and you can say, okay, my machine is this model. I can go out to SESME, I can grab that model, I can pull it down. And if we were to do that, if we were at the maturity point to do that, then you might be able to start using AI on that. But until you get to that point, again, I think all three of us have been very good in not saying that AI is going to magically fix all of this.
A great point.
I'm glad somebody else appreciates that too. I hope the audience does. I think that there's a lot of overlap with, a unified namespace is hopefully something that is so ubiquitous across environments that we'll run into it without folks ever having a you know, a 3-letter acronym that they think of it, right? But the piece about DNP3 IEC is that they are much more sophisticated programming environments and programming interfaces. So they do allow the programmer some response, or force the programmer some level of responsibility for um, um, declaring their comments in their code, or even just naming their variables in a way that they understand will be used by other stakeholders. So there's some user workflow in the devices that implement those standards that really helps the data processing on the other side. They're a lot more going on than, say, the decades we spent, you know, assigning text to Modbus registers and you know, getting everything out of an unsigned 16-bit integer, right? So something like IEC is a little more contextual than DNP3. You know, in 6870 is a bit different than 61850, but all told, the overlap of what we're trying to do with self-describing information fits really well with hopefully some of the interface standards that we all get to use on electrical substations and electrical systems related to VPP. With i3x, I think it's going to be a bit more of an internal data center style or IT style interface, at least for now. And Arlen's right. I mean, there's a lot of work before i3x becomes useful. We have to get things into some sort of self-describing model. And ideally, you don't just take the model that's done by the programmer of that one well site and use that as the model of over i3x. Ideally, that information is a bit more processed, normalized, synergized with all the other stuff in the namespace before i3x happens. But imagine, in my mind, for what it's worth, I think of those standards as giving a leg up to the unified namespace effort and to implementing something like i3x on top.
And they're not mutually exclusive.
Absolutely perfect. Thank you so much. So I think we're coming close to the end of our session. Maybe we have just room for one more question. Maybe I can pause for a moment and see if there is any other questions popping up. If not, I think we can wrap it up. So I'd like to extend a big thank you to our panelists, Arlen, Dean, Sam, for sharing such thoughtful and practical insights. A special thank you as well to our sponsors, Influx Data, for making this session possible. And of course, thank you to all of you for joining us and contributing your questions and perspectives. We hope this discussion provided valuable insight into what it truly takes to scale virtual power plants in today's increasingly complex landscape. Now it's time to move into the next session, Enforcing Compliance Upstream for AI-Ready Operations, sponsored by AdLib Software. Thank you, everyone, and have a great day.